In this video, we're going to multiply a polynomial by another polynomial. Here in our first example, we have a binomial with two terms being multiplied by another binomial. Remember when we multiplied by a monomial, when we just had one term on the outside of the parentheses, we distributed that and multiplied each of the terms on the inside of the parentheses. Now we have more than one term outside this set of parentheses, and we'll distribute each of those to the two terms in the second set of parentheses. That means that the 3x will get distributed and multiplied by each of the terms in the second set of parentheses, and the negative 5 will be distributed and multiplied by each of the terms in the second set of parentheses. Let's start with the 3x. First, we multiply by 2x. That will give us 3 times 2 is 6, and x times x is x squared. Next, we'll multiply the 3x times the positive 1. 3x times 1 is 3x. Don't forget to put the plus because these are separate terms. Now we're done distributing the 3x, so we'll move to negative 5. Negative 5 times 2x is negative 5 times 2, or negative 10 times x. Again, each of these is a separate term. And last, we have negative 5 times positive 1, or negative 5. So here are the four products that we get when we distribute the first two terms to the second two terms. You will often have like terms here, so make sure you look to see if you can simplify this. 3x minus 10x is negative 7x. And we have no other like terms, so this is simplified. Let's look at another example. Here we have a binomial with two terms multiplying a trinomial with three terms. And we'll do the same thing we did in the last example. We'll take each of the terms in the first polynomial and distribute those to all of the terms in the second polynomial. So we'll first multiply the 6x by each of the terms in the second polynomial, and then we'll do the same thing with the negative 7. Let's start with the 6x. 6x times x squared is 6x to the third power. 6x times negative 4x will be 6 times negative 4, or negative 24, and x times x, or x squared. So negative 24x squared. And the last product will be 6x times positive 9, which is positive 54x. Now we need to distribute the negative 7. We can continue writing out these terms horizontally and keep track of the like terms when we simplify, or we can line up the like terms vertically in columns. Let's go ahead and do that in this example, since we'll have a lot of terms to keep track of. The first product is negative 7 times x squared. Negative 7x squared will have to go in the x squared column. Now we have negative 7 times negative 4x. Negative 7 times negative 4 is positive 28 times x. That will go in the x column. And last, we have negative 7 times positive 9, which is negative 63. And we'll need to put that in a new column because we didn't have a constant from the first set of products. Now we can combine like terms by adding vertically. 6x cubed plus 0 is 6x cubed. Negative 24x squared minus 7x squared is negative 31x squared. Plus 54x plus 28x is positive 82x. And 0 plus negative 63 is negative 63. So this is the simplified polynomial that we get when we multiply the two given polynomials. It's important to understand this pattern of distribution when we multiply two polynomials. It will be the same for any number of terms in either polynomial. It can get a little messy to draw all of these arcs if you have more than two terms in the first polynomial. So it's important to remember that you take each term one at a time and distribute it to each of the terms in the second polynomial, and then combine your like terms. Let's look back at our first example where we had two binomials. Here was example 1. This is the same pattern for distribution, but when we have two binomials, we give this a special name. When we distribute the 3x, we first multiply by the 2x in the second polynomial. That's called the product of the first terms. We'll label that with an F for the first terms. Next, we distribute the 3x to the 1 in the second polynomial. This is the product of the outer terms. We'll label that with an O. Then we move to the -5. When we multiply the -5 times the 2x, this is the product of the inner terms, so we'll label that with an I. And the -5 times 1 is the product of the last terms, which we'll label with L. And that's where we get the name FOIL, F-O-I-L, for the product of the first terms, the product of the outer terms, the product of the inner terms, and the product of the last terms. But remember, the pattern is the same no matter how many terms you have in either of the two polynomials. Here's the same pattern, but it's more difficult in this case to come up with labels for each of these products that give us a name that we can remember. Let's end with a third example, where we now have 3 terms in the first polynomial and 3 terms in the second polynomial. Remember, we're going to take each of the terms in the first polynomial separately and distribute them to the 3 terms in the second polynomial. So let's start with the 3x squared. That'll give us 3x squared times 1x squared. That's 3 times 1, and x squared times x squared, which is x to the 4th. So we get 3x to the 4th. Next, we have 3x squared times -5x. 3 times -5 is -15. X squared times x is x cubed. -15x cubed. And finally, 3x squared times 1 is 3x squared. Again, don't forget the plus because these are all separate terms. Now we're done distributing the first term, so we can move to the second term. I'm erasing the first set of arcs and creating a new set for this one because it gets a little bit messy if you try to keep all of the arcs for all 3 of these terms. X times x squared is x cubed. Let's go ahead and write these vertically. So we'll put plus 1x cubed here in the x cubed column. Now we have x times -5x. That'll be -5x squared. We put that in the x squared column. And finally, x times 1 will be positive x, and we'll create a new column for x. Now we're done with the second term. Let's move to the third term and distribute it. -2 times x squared is -2x squared. We'll put that in the x squared column. -2 times -5x is positive 10x. That'll go in the x column. And -2 times 1 is -2, and we'll create a new column for the constant. Notice when we arrange these vertically, we get 3 rows. 1 row for each of the 3 terms in the first polynomial being distributed. Now let's simplify by combining like terms. 3x to the 4th. -15x cubed plus 1x cubed is -14x cubed. 3x squared minus 5x squared minus 2x squared is -4x squared. 3 plus -5 is -2, and -2 plus -2 is -4. 1x plus 10x is 11x, and 0 plus 0 plus -2 is -2. And here's our simplified expression. Multiplying polynomials is not difficult, even with a large number of terms. You just have to remember the pattern for distributing each of the terms in the first polynomial and be able to keep track of all your like terms so that you can simplify.